Now assume there is a car that is totally lost, which means you, as a driver or as a car, have no clue where you are. Now you assume that you have a global map of the environment. In this example, you can see a map of the environment around the Mercedes office in Sunnyvale. Now, generally speaking, localization answers the question, where is our car in a given map with a high accuracy. And high accuracy means between 3 and 10 centimeters. In a traditional way, we use global navigation satellite systems to find the car with respect to the map. But GPS is not precise enough. Most of the time, GPS has an accuracy of the width of a lane, about 1 to 3 meters. But sometimes it can be as broad as 10 to 50 meters. Clearly, this is not reliable enough for a self-driving car. So you can't trust GPS, and you have to find another technique to localize yourself inside the given map. It is common practice to use the onboard sensor data along with our global map to solve the localization issue. So, with the onboard sensors, it is possible to measure distances to static obstacles like trees, poles, or walls. We measure these distances and the bearing of these static objects in the local coordinate system of our car. Now, when you're lucky, the same obstacles that were observed by the onboard sensors are also part of the map. And of course, the map has its own global coordinate system. To estimate where the car is in the map, you have to match the observations with the map information. And when you do it correctly, this results in a transformation between both coordinate systems, the local car coordinate system and the global coordinate system of the map. This transformation should be as accurate as possible, let's say within a range of 10 centimeters or less. If you are able to estimate this transformation, you solve the localization issue. So, after this example, we can summarize. First, localization answers the question of where the car is in a given map with an inaccuracy of 10 centimeters or less. And second, onboard sensors are used to estimate the transformation between local measurements and a given map.